Alright, today we're going to try and retrofit this battery pack that powers the LED strip under my desk to set a DC input so that I could power it off of an AC adapter like this one. So as you can see here, this AC adapter gives out 7.5 volts at 0.2 amps. If I could get this to focus, please. There we go. And it spits out power using this barrel plug. If I could get it to focus right there. There we go. It is focus hunting, which I don't like, but oh well. So the reason for modifying this battery pack is because it draws a lot of power, and every couple of days I need to replace the batteries in this thing. And it's a bit wasteful to throw away disposable batteries every time that happens. So I got a couple of these rechargeable batteries. I could take them out and recharge them whenever I need to do that. Unfortunately, I really don't want to do this every time the battery drains out, and also because the battery pack lives under my desk, it doesn't get moved around. I don't see the real need to have batteries in this thing when AC power is just a little bit away. So if I use this AC adapter to power this LED strip under my desk, I won't have to replace the batteries, which is a good thing. Now I've already used a multimeter to figure out how much voltage and current this thing requires. So disposable batteries spit out 1.5 volts, whereas these ones spit out 1.2 volts. So in total, because there are 3 batteries connected in series, we should get about 4.5 volts of power, give or take, and that's exactly what we see here if I connect it all up like this. And if I use the multimeter to probe between this one and this one, let's see if I can... Oh wait, hold up, that is... Whoops, I just shorted the batteries. I just shorted the batteries because it was in amp mode. Don't do that. So if I just bring the multimeter right over here, it jumps around, but it's at 3.9 volts currently. So about 4 volts. That's expected because these are not disposable batteries, but rather rechargeable batteries. And 1.2 times 3 is about 3.6, maybe 4. It's supposed to be a bit higher than that. So about 4 volts, give or take. And you could also get the current used by the battery pack by simply putting the multimeter into amp mode. So I'm going to put it at the highest amp meter settings. And don't make the mistake that I did. Do not short the batteries when it's in amp mode, because that would be bad. And make sure to change the leads around so that it goes to the 10 amp unfused current measurement plug, right? Now, when you're measuring for current, you don't want to measure between here and here because that would just dead short the batteries and you could potentially cause a fire, so don't do that. What you want to do is you want to break the circuit and you want to put one probe on the actual battery end, so the positive side, and the other on the actual battery terminal so that it shorts and you can get a voltage reading. Now, because I'm doing this with only 2 hands and I have 3 things to hold, I'm going to try and do the best that I can. So when I short these 2 together, I get 0.1 amps ish on the 10 amp setting, which means I'm getting about 100 milliamps of current passing through this thing when it is loaded up at 4 volts. So that means 4 volts times 0.1 amps equals 0.4 watts. So it really doesn't use a ton of power, even at the highest brightness setting using this remote over here. Now, in order to make this project work, we will need to purchase some sort of step-down converter because this AC adapter spits out 7.5 volts, and this battery pack only accepts about 4.5 volts. So we don't want to feed it 7.5 volts because it will potentially fry the circuit inside here. Now, the thing is, before I go and purchase a step-down converter, I want to see if there is a voltage regulator in here, because if that's the case, I could probably just feed it 7.5 volts and it will just not care. So let's take this apart and see what's inside. Okay, so I prized the cover off. There is the cover, and I prized it off using this spudger tool over here. Unfortunately, I couldn't film the process, but it was really easy. You basically insert this tool between the gap over here, and then you just pry up, and then it just comes off like that. It was a little bit hard to take apart because the plastic was welded into place, as you can see here on the left side. This circle corresponds to this hole over here. If I can get it to focus. Yep, there we go. And it was basically welded into place, but I could get it off. And now, there is no circuitry inside the battery pack. As you can see here, it's directly wired to the battery terminal on the positive side, so this one, and on the negative side there is a little switch on the other side to control the current flow, and if you flick the switch, the connection is broken right over here. So in reality, it's just 2 wires going to the control board on the other side. So this is where the wire leads to. Now this board handles spitting out power to the actual LED strip, as well as getting inputs from the IR remote using the IR receiver right over here, this black little thing on the ends. So, and I just noticed that there is actually an output written over here. It says 3x2 amps, so I'm guessing the 3 is 3 volts for the LED strips and 2 amps. So 6 watts, that would be 6 watts. Now that would make this AC adapter not suitable for the transplant if I could get it to focus correctly. There we go. Because this one only spits out 7.5 volts at 0.2 amps, which is 1.5 watts of power, which is 1/4 of the required output of this LED controller. And that means there's also certainly a step down converter somewhere inside the circuit, because it takes in 5 volts and outputs 3 volts. So it will have some losses due to efficiency and whatnot, which means it has to be way more than 6 watts, maybe 7 or 8 watts. This would not be suitable, but that is when we connect the full length of the LED strip to this control board. Now, when I measured the voltage and the current going through this battery pack, I noticed that it was only spitting out 0.4 watts. And this one can certainly handle that, even with the inefficiencies of the control board. So what I'm going to do here is I'm going to pick up a DC to DC converter. I know this is in Korean. Again, I'm in Korea. It just takes in 7 to 26 volts and it spits out a constant 5 volts at 3 amps, and the efficiency is at 96%. It's only 3,501, which means it's about $3.5. Now I know there is one other method that I could use. I could just basically cut this wire and splice together an unused USB cable, and that would be free because, well, an unused USB cable, and I have a bunch of micro USB cables that I don't use, so it would be very trivial to find one. Alright, so sorry for the weird recording angle, but I finally found a victim for this project. So as you can see here, this is a micro USB cable that I had lying around, and it has red X and no data written on it. And it means I tested the cable previously and it did not have any data lines inside of this cable, which sucks, but it's perfect for our use case right now because we only need the power lines to power this thing. So we're just going to chop off the end here. We'll just grab our scissors and we will chop off the end, the headings. The French is going to love that. And then we're just going to use a knife to slice it open. I know that I really need a wire stripper, but I don't have it right now, and if I order it, it's going to take forever to arrive, so I'm just going to use this knife to make a small cut. Great. So let's cut off this sheathing from here. There we go. We're just going to twist it around a little. And same goes for the black wire. What I'm doing right now is I'm basically twisting the ends like so that, because they are little strands of copper wire, so if you twist them together it'll be easier when you solder them. Right here is the battery kit that we need to solder the wire onto. And what I'm going to do is I'm going to grab a black marker and I'm going to mark the spot where it is ground so that I know which wire is ground and which one is not. And what we're going to do is we're just going to rip this out of here. There we go. We're just going to cut off this battery terminal. Alright, no going back now. I'm going to return with a soldering iron and a fresh SD card because my camera is yelling at me. Alright, so we have the soldering thing all ready to go. So I'm just going to use this soldering iron and a bit of solder right over here. I'm just going to dab it on. We have the ground wire all soldered up and ready to go. I'm just going to put a couple dabs more of solder just to make sure it's all fully soldered on. There we go. Okay, and we need to solder the positive end. So now, there we go. Alright, so now that we're done with soldering, I'm going to use this glue gun over here to make sure that the wires don't short out against each other. Okay, so this cable is all done. Now I put some painter's tape over where I put some glue on with the glue gun. So I know this doesn't look very safe, but let me tell you a little secret. This is what we in the industry call good enough, or I'm not paid enough for this. This was entirely free. Like, the painter's tape was something that I had. I'm not going out to the hardware store to buy electrical tape for something as cheap and low voltage as this. And everything here was absolutely free, and that's good enough. So we're going to plug this into a USB charger and see if the LEDs light up and see what the power draw is on the cable. Okay, so we have a USB charger here with a tester connected to it to see the power and the voltage going through, and we are just going to see if it works. All right, 3, 2, 1, go. All right, it's drawing 0.05 of an amp, and so far nothing is blown up yet. So let's press the on button and see what happens. There we go. It was just connected the wrong way. All right, so as you can see here on the USB tester, we are drawing 5 volts at 0.18 amps. So as you can see on the wattage, that's not even 1 watt. It is very low. Okay. And as you can see below, the LED is working perfectly fine. You can see the blue light over there. We are now powering this LED strip using just a USB cable, which is great because now I don't have to fiddle around with batteries. That's it. So this was one of the ways that you could use to potentially convert your battery-powered gadget to use USB power or any other DC power, really. This method that I used today obviously requires you to have a device that accepts 5 volt as an input. Many devices that are battery powered do have a regulator inside of them. You will have to open it up to make sure. But in my case, because the LED strip controller board was fed in 5 volts as an input in the first place, I didn't have to use a step down converter to convert the voltage down to 5 volts. Alright, that's it for this video, and I'll catch you in the next one.